Hello students, greetings to all. Here I am your physics teacher Ravi Kumar. Yes, in the last live class we have discussed on the concept called as a speed concept, right? So there we have studied what is the exact definition for speed, right? And in the speed we have two types, isn't it? One is uniform speed, and other one is non-uniform speed, right? So after studying the uniform speed and non-uniform speed, we have derived a few numericals on the speed concept, right? So by the way, what exactly mean by speed? So we learned that speed is nothing but the distance traveled per unit time or in unit time. The distance traveled in unit time is called as a speed, right? So this is called as a speed. And also we have seen that speed is called as a scalar quantity, right? So what do you mean by scalar quantity? Speed is nothing but a scalar, isn't it? Here, what exact mean by scalar quantity? The physical quantities which only depends upon the magnitude and which does not depends upon the direction, isn't it? So this is called as a speed concept, right? So these are the things which we were discussed in the last class. Now in this session, let us learn the concept is called as a velocity. The concept name is called as a velocity. VELOCITY, velocity. I think we are all familiar for this concept, isn't it? So here the velocity is also known by I can call speed with direction. Speed with direction is also called as a velocity, right? I think something we are getting to our mind that suppose if you have a speed, to represent the speed I can use the direction. So this combination of speed with direction, which is called as a velocity, right? Or the velocity is also known by the displacement per unit time, right? So as we can see in the speed concept, the distance with unit time is called as a speed, isn't it? So as we can see in the speed concept, the distance with unit time is called as a speed, isn't it? If I want to say that the speed has to be gain the direction, so what I have to replace? I have to replace distance with displacement, isn't it? So now the displacement per unit time is called as a velocity concept, isn't it? We are using this velocity component, isn't it? In our daily life, again and again we will use the velocity component, right? So now this velocity can be written in terms of mathematically, that is velocity that is equals to, I can simply write displacement divided by time, or I can write V is equals to D by T, or sometimes I can use V is equals to S is also called by displacement, isn't it? Here S is also called by displacement and time T. So now this is the mathematical representation, how we can represent it mathematically for the velocity component, isn't it? Now, so velocity is a vector quantity, isn't it? We can all agree for this. Why we can call it as a velocity is a vector quantity? Because the name itself saying that the velocity is nothing but a speed with direction, isn't it? If any physical quantity, if we are measuring with both by the magnitude, right? Both by magnitude plus direction or with direction, so that particular physical quantity is called as vector quantity. Now velocity I can call it is a vector quantity. It depends upon the direction of the any particular time, right? Okay. When it comes to the SI unit, right? So we have seen what is assigned for speed concept, what is assigned for speed parameter. So speed can be written as speed is equals to, so distance, isn't it? Distance over time. So how we measure the distance? It is measured by, generally the standard unit, it is measured by meter, and time is measured by second, isn't it? Second. By combinedly, I can just write it as speed. The unit of speed is meter per second. Either I can write meter per second in this format, or I can use